Welcome students to the ACT Help video series. There will be 6 videos that I will be making. Let me explain quickly how this is going to work. On the ACT math part of the ACT test, there are 60 problems. So video number 1, or part 1, will have numbers 1 through 10. Part 2 will have numbers 11 through 20. Etc. until we get all the way down to video number 6, and video number 6 will have numbers 51 through 60. So I am going to make for you 6 videos. Each video will have 10 problems. I'm doing that so you can listen to these at your leisure, at your convenience, and not have to try to pause a really long video somewhere in the middle. Number 2, it's also easier for me to do 10 problems and take a break. Also, one last disclaimer. I am not a poor speller, I am a poor typer, and so throughout this video, as we go from problem to problem to problem to problem, there could be some spelling mistakes. And if that happens, I'm not going to pause the video and fix it. We're just going to laugh and go on, okay? Because our goal here is to cover the math and not to critique my typing skills. So having said that, I hope these 6 videos are a help to you. I am still a teacher at Berean Academy, and you are welcome to contact me anytime that you want to. I am like any other teacher there. My email is earhartm@bereanacademy.net. Okay? And so feel free to contact me if you need to, and I hope these videos are a help to you. Okay, let's go ahead and get started. Oh, one more comment. These 60 problems are right off of an actual ACT test, okay? This is a retired test they no longer used. It was used just this past June, about 6 months ago, so it's a very current test, and I feel it'll be very thorough in helping you prepare for the ACT test, okay? Let's go ahead and get started. Problem number 1. A car was purchased 4 years ago for $26,000. The current value of the car is $17,500. Now let's pause there and comment on that. That makes total sense. Whenever you purchase a car, the longer you have it, it goes down in value. The exception to that would be is if you bought a car, maybe a 1960 or a 1950 car, and you restored it, then it could be worth many thousands of dollars more. But in normal cases, you buy a car and it goes down in value. What was the car's average decrease per year? All right. Now this is actually a pretty simple problem. Probably most of you know what to do, and some of you might skip this part of the video, and that's fine. That's up to you. But if the car started off being worth $26,000, and then 4 years later, which is what it says here, 4 years ago. So 4 years later, the car is now worth $17,500. I'm going to very quickly subtract and just see how much the car has gone down in value. If you subtract those two numbers, you will come up with $8,700. Now that's how much the car has decreased in how many years? 4 years. Does that make sense? And now look what they're asking you. They just want to know what the average decrease was per year. So take your total that it went down and divide it by 4, and you'll have the answer. So if you take 8,700 and divide it by 4, you will end up with 2,175. Let me pause right now and give you guys a little advice. You are allowed to use TI graphing calculators on the ACT. Now the SAT is a little different, so do your research on that. I'm not too familiar with that test. It is a little more difficult, and they are a little more strict. But the ACT test, your usual TI 83s, TI 84s that you use there at Berean, those are totally legal. They are allowed, so use them. So all of this work could have been done very quickly on a graphing calculator. Just type in these two, subtract, divide by 4, and there's your answer right there, letter A. Okay, let's continue on to number 2. For what value of x is 6x minus 3 equals 4x plus 7 true? So in other words, they want to know the value of x that makes this equation true. Or in other words, what is the answer to this equation? Now throughout these videos, I'm going to give you little thoughts and little clues on how to do problems quickly. Remember, the ACT is 60 problems in 60 minutes. So you're supposed to average 1 minute per problem. That's tough. Now, to be honest with you, I have not found these problems very difficult. Now, I know I've had calculus 1, 2, 3, and 4 and all that, but my point is these problems are not that difficult for a high school student. Where it becomes difficult is finishing the problems in 60 minutes, okay? And so with that in mind, realize that sometimes it's quicker to not work the problem out. Sometimes it's quicker to just simply take numbers and substitute them in. Now, that would not be the case on this problem. But for example, real quick students, if this was a quadratic equation, 6x squared minus 3 equals 4x squared plus 7, you know it would be a lot faster, in my opinion, to quickly take 2/5, put it in for x, see if you get out a true statement, then put in 7/8 for x, see if you get out a true statement, then put 1 in for x, etc., etc. Do you get my point? Sometimes it's faster to just take the answers and just work with them. But in this case here, students, watch how fast we solve this. 6x minus 3 equals 4x plus 7. I'm going to bring my positive 4x over. When I bring it over, it becomes a negative 4x, so it's gone. I'm going to bring my negative 3 over. When I bring my negative 3 over, it becomes a positive 3, so it's gone. So I'm left with 6 minus 4, 2x, 7 plus 3, 10, divide both sides by 2, 5. I did that in about 25 seconds, and I was explaining it to you. I could have done it faster if I just would have worked it out quickly, okay? So sometimes you want to plug in answers, sometimes you want to solve the problem. You just have to really be aware of what's best for you, okay? Let's move on now to number 3. Which of the following integers is not a factor of 132? Well, by the way, I'm sorry, let's go back. What were they trying to teach you here, or to test you on, excuse me? They want to see if you remember how to solve simple linear equations. They also wanted to know if you understood the wording for what value of x is this expression true. And whenever a value is true, that means it satisfies the equation. That means it's a solution. So that's what they were kind of testing you on. Now, number 3, which of the following integers is not a factor of 132? Now let's review what a factor is. In this problem here, they want to know if you remember what a factor is. Well, let me show you what a factor is. You know where students become confused? They confuse the words factor and multiples. Okay? If someone says, what's a factor of 132? They get confused. What's a multiple of 132? They get confused. So let's really focus on the word factor. What is a factor? Well, if I asked you to list out the factors of 12, you would say 1, 2, 3, 4, 6, and 12. Those are the integer or whole number or integer factors of 12. Right? All of those numbers go into 12 evenly. So when you're asked, I forgot a C right here, I do know how to spell factor. When you're asked for a factor of a number, you're actually listing out the numbers that divide into that number evenly. Okay? Now, let's go back over here. Which of the following integers is not a factor of 132? Well, look, students, either you're really good with your math in your head or you're not. I don't know. Okay? But I can tell you right now, 11 times 12 is 132. So I know 11 and 12 both go into 132. We know that. And I can pretty much see in my head quickly that 6 goes into 132. I mean, it goes in 22 times. So you can quickly eliminate a couple of them by looking, and then with your calculator, just take 132 and divide it by 6. See if it comes out even. Take 132 and divide it by 8. Oh, stop right there. When you take 132 and you divide it by 8, it does not go into it evenly. You get 16.5. So, which of the following integers is not a factor of 132? 8. 8 does not go into 132, key word here, evenly. So Mr. Earhart, you're telling me 33 does? Yeah, 33 times 4 is 132. So the only number in this list that does not go into 132 evenly is 8. Please do not forget what the word factor means. It means small little numbers that go into this number evenly. We'll talk about multiples later, okay? All right, number 4. A vending machine only accepts quarters and nickels. When the machine was emptied Friday afternoon, there were 325 coins. So there's your total coins. There was a value, the actual cash value, when they counted up all the coins, and did all the math on it, was $56.25. That's the total value. Which of the following, there's our first typing mistake right there. Woohoo! Which of the following systems of equations, when solved, gives the number of quarters Q and number of nickels N? Now, very quickly, first of all, this is a simple Algebra 1, Algebra 2 word problem. I know this for a fact because, first of all, my son is taking Algebra 2. I know Miss Walker teaches this. Number 2, I've taught Algebra 1 and Algebra 2. This is not, unfortunately, a super difficult problem. Now, some of you who struggle in math will struggle with this a little bit, but it's really not too bad. Let's talk about this, okay? First of all, I want to draw your attention to a couple of things. Notice we have two unknowns. We don't know how many quarters we have, and we don't know how many nickels we have. Do you see that? Pretty obvious. Well, when you have two unknowns, usually you're going to want two equations. Okay, so if you have two unknowns, you're going to try to come up with two equations. All right, that's a key phrase. Another key phrase is, and of course, I'm going to put the word usually here. You have to be very careful saying always. And I also want to say usually, here's another key phrase you might want to make note of. Usually, you want to look, and again, I'm not trying to impress you with my handwriting. I'm going to go fast, okay? Usually, you want to look for totals somewhere in the problem, like total coins, total value. Okay, now you know why you want to look for totals? I'm glad you asked. Thanks for asking. Because in most equations, you're adding or subtracting something and it equals a total over here on the right side. So that's usually what we're going to look for. Okay, so instead of trying to go through, this would not be a problem where you would want to look at each equation and see if it fits the situation. That's just going to confuse you. Look at all these numbers and decimals and Q's and N's. Okay, so what I would just simply say is this: hey, I've got a total of 325 coins. I need to come up with two equations that are good, solid, true equations. So I know that I have a total of 325 coins. So it makes total sense to me if I take all of my Q quarters plus all of my N nickels, it'll equal 320. That makes sense to me. I mean, come on. If I've got 100 quarters in the machine, then there would be 225 nickels, right? Sure. If there were 200 quarters, then I would have 150 or 125 nickels. Okay? So that's a true equation, and that's a good one. And notice how it used a total. Now, there's another total I see in the problem, and that's the value. And the value is 56.25. Now, I'm dealing pretty much with juniors and seniors, so I'm going to be a little sarcastic, a little humorous. I think most of us know that a quarter is worth 25 cents. So if I have 4 quarters in my hand, now watch this, and I multiply 4 times 0.25, I get out this right here. If you don't believe me, go ahead and type it in your calculator. You'll see 4 quarters times 25 cents gives me $1. So in other words, I can take every quarter that I have. Now, do I know how many quarters I have? I have no idea. But I can take every quarter that I have and I can multiply it by what? 0.25. That makes sense. And I can take every nickel that I have. Hold on one second, please. I can take every nickel that I have and multiply it. Oh, be careful. You know what a lot of students do? They put 0.5. And look what the ACT people do. They try to trick you right here. In letter G, they put 0.5 or 0.50, which is the same thing as 0.5. Guys, 0.50 is 50 cents. Now, I wish all my nickels were worth 50 cents. Okay, I'd be a lot richer than I am right now, but they're not. A nickel is worth 0.05. So every nickel that you took out of that machine, you would multiply it by 0.05 or 5 cents. Now, if you do that correctly, when you add all of this up, take all of your quarters, multiply it by 25 cents, take all of your nickels, multiply it by 0.05, all of that will equal equal, excuse me, $56.25, okay? So again, some of you get this, you're bored, you're sleeping, you're moving on, others are struggling. You might want to back this up and listen to it 2 or 3 times. I know that would be the highlight of your day, and yes, I'm joking, but this is the answer. This is the system of equations that would give you how many quarters and how many nickels that you have. And by the way, here it is right here. Number 4 is letter F, I believe. Let's see, Q plus N. Yes, that is the answer, letter F. Okay, let's continue on to number 5. Carlita or Carlotta, maybe it was Carlita. Well, maybe I typed it wrong. Either way, Carlita is helping her grandfather center a large frame picture on his living room wall. As shown in the figure below, the rectangular wall is 24 feet long, and the rectangular frame picture is 4.5 feet high and 7.5 feet long. The left edge of the frame will be X feet from the left edge of the wall, and the right edge of the frame will be X feet from the right edge of the wall. Now stop right there. When I was reading this problem, I thought they were going to say something crazy like find the area of the shaded part, you know, or find the area of this space right up here. But it's really an amazingly simple question. What is the value of X? So here's X right here. Do you see it? The distance from here. Let me change colors so you can see it a little better. X is the distance. Not much better. X is the distance from here to here, right here, from this space to this space. And X is the distance from here to here. I mean, they've given you a picture of, I copied this right out of the book. I cut and pasted this right out of the ACT book. So that's what we're looking for right there. Would be the value of X. Now think about this. Please watch this, guys. Look at this whole line. This whole line right here is 24. Do you see that? Okay, so I'm going to come down here. I'm going to draw a line that's supposed to be the same length. And the whole length is 24. Now, I know from here to here is 7.5. Do you see that? Now look, if X is the distance from here to here, would that not also be the same distance down here from here to here? Well, sure it would. You could put a big rectangle right here, just like that. And this side here is the same as this side here, okay? And same thing on the left side over here. Look, this distance right here is the same as this distance down here. If I drew a rectangle just like this side here would be the same as this down here. Okay, Mr. Earhart, fine, but what are you trying to show us? Just simply this, that this distance from here to here is X, and this distance from here to here is X, okay? So if the whole distance all the way across is 24, then I'm going to take 24 and I'm going to subtract out 7.5. So 24 minus 7.5 should be 16.5. Okay, now notice they gave you that answer right there. They're trying to trick you. They gave you 16.5, and that's wrong. When you subtract out 7.5, what are you left over with? 16.5. But hold it, that 16.5 is for this distance here and for this distance here. So we're going to have to take 16.5 and do what to it? Divide it by 2, okay? And then when you divide it by 2, you'll see that the right answer for number 5 is A, 8.25. 8.25. So the whole distance is 24. We subtract out 7.5. We're left with 16.5. Divide it by 2, and you're left with 8.25. And that is hopefully a pretty simple problem, okay? All right, moving on to number 6. In triangle ABC, the sum of the measures of angles A and B is 57 degrees. What is the measure of angle C? Now, I think it's always very helpful to get a quick picture. Now, that's just me. Now, I know you've got 60 minutes for 60 problems. I get that, but still, I think it's helpful sometimes quickly to do this. Now, it says the sum of A and B is 57. So that means if you add these two angles together right here, these two angles, they're 57 together, okay? Now, I don't know what that means. I don't know if one of them's 30 and one of them's 27 or one of them's 40 and one of them's 17, whatever. But both of these angles added together is 57. Now, you should know by now, and by the way, here's what they're teaching you. They're teaching you in this problem. Are you ready? The sum of the interior angles of a triangle equals 180 degrees. Please never forget that. That's very important. That could probably very well influence one day who you marry. Okay, I'm kidding, but you need to know this. The sum of the interior angles of a triangle is 180 degrees. Now, if these two added together is 57, then I'm simply going to take 180 and minus 57, and I'm going to get 123 degrees. So angle C is 123 degrees. Now, I'll bet you, I've not done this yet, but you know what I think they wanted you to do? I think they might have wanted you to do this, to put a 57 here and a 57 here. Let's see if we have an answer, a wrong answer over here that would match this. 57 plus 57 is 114. That would be 20, that'd be 67 degrees. What did I add wrong? Maybe, let's see, 4 carry 1, 114, 180, 20, yeah, it'd be 66 degrees. So they wanted you, I think, to put 66 degrees. They wanted you to read this problem and think that each one of these angles was 57 degrees, and that's not true. The sum of the measure of A and B is 57. What's the third angle going to be? So each of these angles are not 57, students. Add them together and they're 57. So the other angle has to be 123 degrees, okay? And I know my triangle is not drawn to scale, and that's not a big deal to me. All right, number 7. A square and a rectangle have the same area. The length of the rectangle is 32 centimeters. The width is 2 centimeters. What is the length of a side of a square? Again, there's a balance between, I had a soccer coach back when I weighed 150 and not 250 100 pounds ago, and I was a goalkeeper, and he would tell me to distribute the ball quickly but not hurriedly. In other words, quickly get rid of it, but not hurriedly in a rushed manner where you make a bad decision. I think that's very important for this test, ACT test. You need to work quickly but not hurriedly, because it does no good to work so quickly you miss the problems, but you have to work so slowly you only get half of them done. So we're going to go with the philosophy, quickly but not hurriedly. So I very quickly realized it would probably behoove me greatly to draw a square and then draw a rectangle. I can do that very quickly, okay? And then I can say the length of the rectangle is 32, the width of the rectangle is 2. So what would the area be, by the way? The area would be 64. You know what they're testing you on here? They want to know if you remember how to find the area of a rectangle, length times width, and the area of a square, which is really length times width also, even though it's the same size. Or you could say L times L, or I guess you could say side times side if you wanted to, because a square does have the same length for all sides. But anyways, that's what they're testing you on here, and also your ability to reason here. So do you see what I did? Length of the rectangle, 32. Width of the rectangle, 2. Multiply 32 times 2 and you get 64. Now, it says right here in the first sentence, do you see this? The square and the rectangle have the same area. Oh, booyah, that's a big help. So if the area of the rectangle is 64, what's the area of the square then? 64, good. So what's the length of the square of one of the sides? Well, guys, look, it could be, we could try something like, oh, I know, it's 4 and 16. Well, 4 times 16 is 64, but it's got to be the same side. Oh, I know, it's going to be 3 and 32. No, it's not going to work. The only two numbers that when multiplied together give me 64 that are the same numbers would be 8 times 8. Do you see it? So if 8 times 8 gives me 64 and they're both the same number, then the length of a side of the square has to be 8. It has to be. So there's the answer, 8. All right, so they're testing your ability to remember how to find the area of a rectangle and a square, and then how to apply the problem and kind of use reasoning skills and realize, okay, they have the same area. So once I know the length and the width of this rectangle, I know the area. Then I know the area of this square, so I should be able to find one of the sides. All right, number 8. As the motivational speaker, Bree speaks at school assemblies, charging a school district for her travel costs and a fixed amount per assembly. Bree used the equation C equals 50A plus 1500 to determine the charge of C dollars to speak at A assemblies in the, I'm not sure, Escambia City School District. Bree charged the district $4,250 to speak at school assemblies. How many assemblies did Bree speak at in this district? Now, this is going to be a difficult problem for some people who struggle in math, and I understand that, but maybe I can kind of throw some thoughts out at you. First of all, they're teaching you how to interpret a linear equation. Here's your linear equation. C equals 50A plus 1500. Now, whether you're good in math or not, you should see right away that there's a one-time charge that doesn't change, 1500. Okay, and then notice the 50 here gets multiplied by A. Now follow my pen, please. What does A stand for? She's charging C dollars. Let's go ahead and make note of that. I wasn't going to. Let's go ahead and write it down now. C stands for dollars. To speak at A assemblies. So A would be the number of assemblies. Got it? Abbreviate it. Number of assemblies. So every assembly that she does, she charges how much? Can you not tell by looking at this? This is called interpreting a linear equation or a linear model. Every A is getting multiplied by what? 50. So that means every time she speaks at an assembly, they give her $50. Now, does that mean every time she speaks at an assembly, she gets $1,500? No, there's no A right here. She got a one-time travel expense payment of $1,500. Paid for her meals, her hotel, her airplane, whatever. Okay, rent a car, gas, etc. So they give her a one-time payment of $1,500, and then as she goes around to all these different assemblies and speaks for a whole week, she gets $50 per assembly. So she's not getting rich off the assemblies. She probably makes most of her money here, part of her money here, and then also she makes money on the assemblies. So with that in mind, now that we've kind of broken this down, excuse me for a second. Now that we've broken this down, let's see what they're looking for up here. Bree charged the district $4,250 to speak at school assemblies. That was her total dollars. How many assemblies did Bree speak at? Okay, there's two different ways to do this problem. I'm going to break it down two ways. And again, students, don't forget, you can fast forward this video all that you want to. If you're finding this boring, I get this, that's fine, go on, okay? But for those that need help, please watch. Okay, one thing you can do is you can take your equation right here, your linear equation they gave you, and notice, sorry about that, and sorry about that again, I guess I can't do this. It's not going to work. Okay, you can take your linear equation here, and where the C is, you can substitute 4,250. Are you allowed to do that, Mr. Howard? Yeah, why not? I mean, that's how much money she made, and that's what this equation is. It says total dollars, total. Put the word total here. Total dollars and total number of assemblies. So you can put 4,250 here and solve for A. And A stands for what? The number of assemblies. And what are they asking for? How many assemblies did she speak at? So let's bring the 1,500 over and make it negative. And when you do that, oh, what would you get? You would get 3,000. I think you get 2,750. I'm trying to do that in my head, which is kind of scary. I think that's right. So we're going to bring the 1,500 over, and we're going to make it negative. And then we're going to divide both sides by 50. So I think we would get 50, let's see, 55. Let's check my sheet here and see if that's the right answer. H, yeah, that's the right answer. So divide both sides by 50, and you get 55. So there's how many assemblies she spoke in, 55, letter H. But there's another way to do it. You could just say this. Oh, this is so easy. They paid her 4,250. We know right off the bat she gets 1,500, so I'm going to subtract that out. When I subtract it out, I'm left with 2,750. And I know she charges 50 per assembly, so I'm going to divide it by 50, and when I do that, I get 55. Either one of those two, and by the way, some of you are looking at this method here and saying, that's dumb. And others of you, because you think differently, you're looking at this over here and saying, that's dumb. I like this one over here. Every student's different, okay? But the main thing is they want you to interpret a linear model. They want you to understand what it's saying and then reason out how to find the number of assemblies. By the way, this is a really practical business problem here, okay? All right, let's move on to number 9. Let A and B be positive prime numbers. Now let's review what positive means. Anything greater than, I'm going to say X stands for your numbers. Anything greater than 0 is positive. What's prime? Y'all remember what prime means? Let's review. That's what they're testing you on. A prime number is a number that nothing divides into it evenly except 1 and itself. The first prime number is 2, not 1. So 2's prime, 3's prime, 4's prime. Is 4 prime? I did that on purpose, is it? No, not at all, because what goes into 4? 2 does. It has to be a number that only 1 and itself goes into it. 5 is prime, 7's prime, 9's prime. Well, 9's not prime, is it? Because 3 goes into 9. 11, etc. So that's prime numbers. Let A and B be positive prime numbers. Which of the following numbers must be a factor? Now, guys, about 6 or 7 problems ago, do you remember? I was showing you, I was reviewing what factors are. Factors are numbers that go into a given number evenly. Okay, that's what a factor is. Let's go back to this problem. Which of the following numbers must be a factor? Or another way to say this, which of the following numbers must divide evenly? That's what factor means. Divide evenly into what? Both A and B. Now look, we have no idea what A and B are. We know they're prime, we know they're positive, okay? So what's the following factor that must, emphasis on the word must, which of the following numbers must divide into A and B evenly, okay? Well, it's going to be 1, okay? I'm going to tell you right now, and let me explain to you why it's 1. If you have A and B, would A, well, first of all, 0 is not going to go into A and B evenly, okay? I mean, 0 is going to go to it 0 times, okay? You can't divide by 0. That's impossible. It wouldn't be A because, I mean, A goes into A evenly, but A is not going to go into B because both of these numbers are what? Both of these numbers are prime, okay? It's not going to be B. I know B will go into B, but B won't go into A. Students, there's no way it's AB. Let me tell you why. Let's say A was 7. That's a prime number. Let's say B's 11, okay? Let's multiply. They're saying A times B. Let's multiply these two numbers together and we get 77. Does 77 go into 7? No. Does 77 go into 11? No. Do you know why they put that there for an answer? They're wanting to see if you'll get the word factor confused with the word multiple. You see, 77 is a multiple of 7 and 11. 7 times 11 is 77. But 77 is not a factor of these numbers. Remember, a factor means a number that divides evenly into. And 77 does not go into 7, and 77 does not go into 11. So 1 will definitely go into 7, or whatever prime number you have here, and evenly, and 1 will definitely go into B evenly. So they're testing they're testing, do you remember the definition of a prime number? And they're testing your ability to remember the difference between a factor and the multiple of a number. I hope this helps. Number 10. What is the value of this when x equals 4 and y equals 6? Now students, use your graphing calculator. Use your graphing calculator. I would type it into my grapher just like this. Exactly. Go ahead and practice if you want to. I would type in 80. Man, I would go so fast I would fly through this. 80 minus, and then I would put 5, then I'd put a parentheses, and then for x, I'm putting 4. So I would hit 4, and then if you'll look at your calculator, let me see if I can pull something up here real quick for you. Okay, I was able to pull something up here quickly for you. Notice it's 80 minus 5, then parentheses, then for x, I'm going to put 4, and it's 4 squared. If you'll look at a standard typical graphing calculator, and that's not what I wanted. Hold on one second. This button right here is your x squared button, okay? Right here. X squared. Why it's not working, I don't know. But anyways, this is your x squared button. Hopefully you can see my mouse there moving around. This is your x squared. So I would hit 4 and then this button right here, and up would pop a little 2 right here. And then next is minus. minus, and then for y you're going to put a 6. So I would obviously hit 6 and then close my parentheses. By the way, if you don't know where parentheses are in the graphing calculator, they're right here. See my mouse moving? There's 1 and there's 1. Okay, in fact, I'm going to go ahead and do this. I think it'd be very beneficial to help us have this on the screen next to the problem. So there we go. All right, now let's continue on. Okay, now here's your parentheses. There's a parentheses, and there's a parentheses if you did not know where those were. Now, notice next that I would have plus y. So a plus sign, and then for y I would have 6. So on your screen here it should look just like this. It should be 80 there, 5 parentheses 4 squared minus 6. Close your parentheses plus 6, okay? And then hit enter. And if you hit enter, up pops the answer, H, 36. There it is, 36. Now, remember, I don't want to be long-winded. I'm only doing 10 problems at a time. But guys, look, I want to teach you, okay? And I have a concern. You do, Mr. Error? Yeah, I do. And my concern is on the test, they might give you something like this. It might give you one with a -4 and a -6. So can I please very quickly show you how to type that into your grapher? It's really, really, really important, okay? First of all, you would write 80. And then minus, and then a 5, then hit parentheses. And then inside that parentheses, it's okay to hit parentheses again. So, and here's why. When you're putting a negative number in for x and then squaring it, you had better put that negative number in parentheses and then hit the exponent. If you don't, you will miss the problem. Okay, and then notice there's a negative sign next, and then notice you're putting a -6 in, so use parentheses again, -6, then close your parentheses, then put another parentheses which tells the computer that you're closing off this whole area right here. Okay, now if you got to back this up and watch it again, feel free to. And then next is a plus sign, and then you're putting a -6 in, so use parentheses again. And then hit enter. You should become very quick at typing these in, okay? All right, part 1 is over. I'm sure half of you are asleep. Hopefully this has been a help to you, and feel free to view part 2 whenever you're prepared to do that.